can just title this 7.10. But this is it's actually the way that I teach it is going to be very similar to what we've learned already with volumes of a solid with a known cross section. I actually teach it almost identical to the same way. Most teachers don't, but it actually is pretty easy. So we're going to just do it that way. What it is if you take an object and you rotate it, and it would create a solid if you were to rotate it. Okay, so that's what we're talking about. We're going to learn how to find those types of solids today, their volume. And that's our last topic. We're going to spend 2 days on it. So let me demonstrate for you. So right here on the left, I have a square root function. This is the square root of, I don't want that there. Let me get rid of that. Huh. Interesting. So we're looking at a square root function, right? Now, what we're going to do today is we're going to take a function and we're going to, of course, take this into the three-dimensional world like we always do, right? I want to get this to be situated in a certain way, so bear with me here.
You're almost there.
I'm still not happy. I want it to be.
You're almost there. You almost got it. You're right there. There you go. Oh, no. The other way?
There we go. That'll work. All right. So we're looking at this at kind of a funny angle, but we're looking at it in a three-dimensional way. Now, we're going from A to B here. We're integrating. But what I'm going to do now is I'm going to revolve it around the x-axis, and as I do that, it generates like a cone shape. Sure. So that is the result of a solid of revolution. So what a solid of revolution is when you take a function and you rotate it around some axis, and as you do that, it creates the object. Now, the way that I'm gonna teach this is actually pretty much identical to what we learned last time. The way that I'm gonna teach it is I'm gonna say you have your function, right? And we have a cross section. What is my cross section? What shape is that?
Circle.
It's a circle, right? Yeah. And the area of that circle is going to be pi r squared, right? And the r is simply the distance of your function to the axis, right? So it's just going to be pi r squared, and then we're going to integrate it from here back and add together all those areas of circles all the way back, and you get the total volume of the shape.
So,
yeah.
So we're actually solving two equations. We're solving the radius of the circle, and then we're also solving the height of the function.
Yeah, there is a little bit of a difference there. So sometimes the function will just be the radius, but sometimes you'll see that they're not the same.
Okay.
And we'll see two different examples of that today. Was there another question over there?
No.
Okay. So that's what volumes of revolution are.
Yo, it's like it's still there.
Let's begin our lection.
You just said let's begin our English.
I'm pretty sure lection is lecture, lesson, isn't it? All right.
English. No, not in Spanish. I'm just saying lexion is a fancy word for saying like the English language. What? The language is lexion. I think it's like Latin.
Okay.
How do you know?
So we're going to start off, like I said, with a function. So we'll call this function f of x. Actually, you know what I think I'm going to do is I'm going to not have the axes on here at all. I don't want them there. A lot of times they will be there as our actual axis of revolution, but I don't want you to think that because they don't have to be. Then the next thing we're going to have is we're going to have an axis of revolution. Yeah, that's the line that it spins around. The distance from there to there, from the function to the axis, is our radius, which I'm going to call r of x. Okay? How do you find the distance between a function and the axis? What do you think? Well, actually, we're trying to find the radius. So how do we find the radius?
R squared.
No.
Oh.
There you go. So you do f of x minus
0.
whatever your axis is. So on the problem that I showed you earlier on the demonstration, that would be 0. But it doesn't have to be 0. It could be anything. So it's going to be f of x minus the axis, or it could be the axis minus f of x. How would you know when it's one way?
Positive. So if the graph is above,
Whichever one's on top, right?
I was right.
Whichever one's on top. So if the axis is underneath, it's the function minus the axis. If the axis is on top, then it's axis minus the function. Now, as you guys know, after that, we are going to rotate it, right? So here's my radius, right? It's going to come down here, and we're going to rotate around that radius. And that creates a circle. Now, the area of that circle is going to be pi, whatever your radius is, squared, right? Yeah, what's up, Nicola?
So are we gonna? Do you want us to actually draw these?
Well, that would be nice, but it's your notes.
Okay. No,
So
I mean
I
like.
don't really check things in that much
like
detail. Oh, you mean like on the exercises?
Yeah.
No, I won't require that.
And for the test, do you want us to do it or no?
Nope. The only reason why I encourage drawing the pictures as you go is because it helps you connect the concept to the process and be a little bit more creative with the solution process. All right, so we have our function. The distance from the function to the axis is the radius. We're going to be spinning this thing, so the area of the circle that's generated will be pi r squared, and therefore the volume will be the integral, the sum of all those areas put together from whatever your starting point is to whatever your ending point is. Okay? So in this case, A and B would be like from here to here. Okay, that's it. Yeah. You definitely can do it with respect to y. And the only difference would be is that obviously these will be r of y's now, right? F of y's. That's really the only difference. I guess the other difference would be how do you know which one's on top, right? Well, which one comes first? Well, now it's the one on the right versus left, right? Other than that, it's all the same. Yeah.
So if it was in respect to why like where it rotates the axis of revolution.
Yeah, so what you could do, like, so I'll draw you guys a picture of one. So here, let's say I had this. So if I had that, then I would have to, this would have to be some function of y. My radius is the distance from here to here, right? And then if I rotated it,
Yeah.
it would look something like that, right? Yeah.
That's like half a lemon.
Yeah, I agree.
Or an apple.
And so and once again, your limits go from here to here now, top to bottom instead of left to right. All right, let's do some actual problems now. I did print these out for you. Some of you guys were asking about printouts. I did print this out for you. So let me get that for you now.
What a G, bro. You really just say what a G.
So here's our picture. We could see we have this parabola here. We're rotating this image around the x-axis. That's what that little arrow means. This function here, the x squared plus 1, is obviously this piece right here that's curving. And then they also want us to bound it between y equals 0, x equals 0, and x equals 2. So that, in other words, they're just kind of trapping that whole little area right there. That's why they give you all those equations.
And this is respect to y. No,
Nope, we're only going to do respect to x, and we'll get to the respect to y later on today. All right, so here we go. Step 1 is to find your radius. So let's do that. So my radius is, remember, it's the distance of your function to the axis, right? So my function in this case is x squared plus 1.
So it'd be 5.
Right?
Yeah.
Minus my axis. What's the axis of rotation? What's the equation of that line?
0.
The equation of that line is y equals 0. So it's minus 0. And so the radius is just the function in this case. So anytime your axis of rotation is actually just the x-axis, then the radius is just the function. Okay? Next we're going to do the area. Now, as you guys know, area is going to be pi radius squared. I forgot to write equals r of x there. So it's going to be pi, and we said that my radius was x squared plus 1, right? So pi x squared plus 1 squared. And then the volume is what I get if I were to take one of those circles and then integrate all the way back. Add all those little circles together, right? So volume will be the integral, pi on the outside, x squared plus 1 squared dx. And we're going from what to what?
0 to 2.
0 to 2. And that's it.
My question is, will it ever not be a circle or cylindrical?
When you're doing revolutions, they will have to be circles, yeah.
But what if you like
Because it's a circle.
So you know how we had it? Stop making me feel dumb, alright? How are you done? Towards the alright then before you put it up.
Yeah.
If it was in respect to y, but it was still like that, would it ever be like that? So
Yeah.
it'd be like a big circle.
Yeah.
How do you know?
Yeah.
So there'd just be like a hole.
That's called the washer method. We're going to learn that one tomorrow.
Okay.
So you can actually have two things where it
Yeah.
leaves a hole in the middle. We'll talk about that tomorrow. And it's actually just the same. Setting it up is a little bit harder, but the idea is exactly the same. All right, let's go ahead and take a look at another example. Number 2 is a student practice, but I'm going to leave that for you guys for now. I'm going to jump on over here to number 3, which is another one. So let's do that. All right, so let's find our radius first.
Yo, it's literally just a white spot.
You guys don't have a...
No, I don't.
Let me see yours.
So if you guys want to... Oh, yours came out bad.
I don't see what you're talking about.
Here you go.
What's a white spot?
I don't know if you want it or not. All right. So radius is f of x minus the axis. Or don't forget, it could be axis minus the f of x, right? In this case, though, my axis is underneath of the function, so we're good. So my function, in this case, what's my function? It's radical x plus 1 minus, what's my axis? This time I have a different axis, right? It's actually a number. So the radius of my circle from here to here is f of, yes.
The one is outside of the one's supposed to be outside.
Oh, okay, thank you.
Hey, that's I said it.
No, I'm Hercules.
Everyone gets the pencil.
What?
Wait, I didn't even know.
Yeah,
I really would have just
Yeah.
What about?
All right, so that means my radius is going to be square root of x. So that radius is this distance here. Now what we're going to do is we're going to rotate this. I don't like how I drew those last ones. They're a little bit off. This should be shorter.
Get your head up, Will. We're doing math. I will.
Okay, so the area. Pi radius squared. My radius is the square root of x.
So it's just
X pi. So the volume will be pi integral x from 0 to 4. There you go. Not too bad, eh?
Hey, Canadian.
Not a Canadian.
Why'd your New York accent?
All right, here we go. So Sean, what's my radius on this problem? Number 2, please.
Radius is radical sine x minus 0. You don't need the 0.
So we don't need the 0. Lucia, what's the area of one of the circles of revolution?
No radical, Mr. Really. No radical. Sorry. No radical.
You're good.
Just
Pi what? Pi sine x, and that's because it's pi r squared, right? And then that cancels the root.
Is that an L?
No, it's a 2.
It's not your grades,
So
though.
the power of
He's not posting.
I don't know your grades, so I hope it's not bad, but I'll leave it at that.
What is my grade, baby? Let me see what you
I'm
got.
not looking. Then my joke will just make me sad if I do that. Come on. Art, what are our limits?
Our limits are 0 to.
I have an F.
I don't know.
That one seems to get people. It's right here. So you see, we have this curve, the sine, right? We have y equals 0. That's this line. And then we have x equals 0, which is here. That's your left barrier. Your right barrier is 2 pi over 3. And of course, we like our dx's. All right. So let's continue. Number 4.
Let me solve number 4.
No.
Mr. Bailey!
Daniela, what is my radius on number 4 for the circle of revolution? That's the final radius because you have x squared plus 2 and you subtract from it the axis, which is 1, so you end up with x squared plus 1. And I'm going to ask David, what's the area of a circle of revolution?
It's pi times x squared plus 1.
Yes.
And therefore, to find the volume, Aaron, we're going to integrate from what to what?
Whoa,
That's. You just did all of it in one spot.
Yes.
Okay, pues.
All right. Next, we're going to continue our journey in finding the volume of these solids of revolution. All right. So this one's really kind of hard to see. I don't like how tiny it is, but you guys see it?
That's the one?
That's the
Oh,
one.
you're a nerd.
I am.
Oh, it's so
Thank
small.
you.
I love
Appreciate
that. Yay. Ew, this is respect to why?
You change everything when you put these voices on. You become that whole person. Your entire body language changes. That's pretty good.
Hey, I'm a method
I see that. All right. Let's do some math. Ready? Okay. So now we are going to be rotating this, as you guys can see, about a vertical axis. When you're rotating it about a vertical axis, now everything's dy instead of dx, right? All right. So they've already got the function solved for x for us, so that's nice. So here's my x cubed here, and then we have x equals 0 here, and then y equals 1 here. So that's that tiny little piece there, and if we were to rotate it, you would end up with a shape that looks something like this, right?
Who's like a vortex?
Yeah, like a little tornado.
That looks like a calculus shape right there.
Oh, well, it is. All right. So, radius time.
Radians.
So my radius, in this case, r of x, is going to be...
Still, no, that's
R of Y, fam.
Oh, I'm sorry. Thank you.
au revoir. That's axis minus f of x. That's axis minus f of y.
No.
Yeah, because 1 is the axis, isn't it?
No.
This is 0.
It's y over 3 minus.
So what is the axis?
Wouldn't that be the 1?
0. 0 on the axis.
Oh,
yeah.
So it's 0.
So
And
f of x
the curve is located in what direction to the axis? To the right, which means that which one's bigger?
the right.
The function's bigger than the axis because it's to the right.
Yeah.
To know which one's bigger when you're going on with respect to y, it's the one to the right that's bigger. So it's going to be f of y, which I really shouldn't call it f of y because they didn't define it that way here. So I guess maybe I'll do that here just to be consistent. So we have f of y minus 0. So my radius
Y to
then
the third.
is going to be
Y to the third.
y to the third minus 0, which is just like you said, y to the third. Now, the area of a circle that is thus generated would be pi r of y squared. So that's going to be pi y cubed squared, which is pi y6. And therefore, the volume of revolution would be
Pi integral 0 to 1
dy.
6 dy
now the limits
0 to 1
are 0 to 1. Do you guys see why?
Yes, I do.
because it's on the y. No, show me.
I do very much see that that is a y to 1. 0 to 1.
Can I show you what?
Show me why it's 0 to 1.
Okay, so the question, so remember whenever you are integrating with respect to y, instead of taking your limits left to right, it's bottom to top. So from y equals 0 to y equals 1. Actually, though, if you were going left to right, it looks like you'd get the same thing. It's kind of interesting. All right. Well, let's go ahead and continue the journey. Let's go ahead and take a look at number 7. Let's go ahead and take a look at number 7.
Why does it say axis equal x equals -1?
That's a good question.
That's where they want to rotate it from.
Yeah.
I see you, dog.
Yeah.
I'll show you, dog. Right?
Okay, so here's my curve. X equals negative y squared. I'm on number 7 right now. So here's the curve negative y squared. X equals -1. So that they're telling me the boundary. It's to the one left. And then y equals -1 is my lower boundary. Y equals 0 is my upper boundary. And so we're just kind of capturing that little chunk right there. Now, the axis we're rotating it around is the axis right here. So it's not 0 this time. The axis is -1. So here we go. Radius is r of y. R of y.
Yes, sir, I do believe that it is r of y. It is negative y to the second minus 1.
Negative 1.
My function is
Negative y to the second plus 1.
good. Minus a -1 is going to be +1. So my r of y sounds like au revoir. Au revoir is 1.
You can't do that. It's a negative y.
What? I don't hear you guys. What?
It's a negative y.
Where? What? Oh, I just had to fix something. What do you want to say?
The video says so.
All right. So there's our radius. Therefore, the area would be.
You better put my points in.
I'm a big man.
You haven't been doing that for me.
I don't
the
think
volume
he
is
just
the
it's all
He
does. He's like, yeah, you get points. Don't worry about
I
it.
give you good points.
He,
All right.
he goes and pretends to put a check mark on there. He's like, this class gets too many points.
All right, what are my limits?
Negative 1 to 0.
You forgot your DY.
DY. There's not enough room for your DY.
Yeah, I couldn't fit it.
I don't get it. Mr. Bailey, where
Yeah.
did power 2 go? Yeah.
You forgot 2.
Yeah, but say
Power 2.
Oh, I forgot to square my radius.
There's
That's
not
a point
enough for
for me to
Can't you plug it in that equation or no?
You like that shit?
Can't you like plug it in that equation? Or
Plug
do you,
what
do you want
into
Do you
what?
want us to like split it up and then FOIL it? Or no?
Not unless I said to integrate this by hand. If you're using a calculator, I'd leave it just as is.
So, quick
Why are
question.
you club?
Now that it's y, right? It's whichever's the furthest to the right minus the farthest one to the left.
Leave it up there for like 2 seconds.
Okay.
I have to do
So my radius for this one is,
it would be 4 minus 1 in a second. That's you could write it like that. Hey, so they didn't pass their points all over.
no, you were right the first time. All right,
Well, can't you write
next.
4 minus 1 in a second?
No.
Positive 4?
I think you'd end up with the same answer anyway, but I
That's what
wouldn't
you did with,
encourage
the other one.
you. No, on this one, this has to come first because it's to the right of the axis.
Fine, I get it.
All right, next. Okay, guys, quiet, please. Luke, what is the area formula for a circle of revolution there?
Pi negative 1 in a second.
Good. And therefore, the volume would be what, Noah?
From 0 to 2.
0 to 2 is right. It's kind of hard to tell when you're looking at an axis or an axis of revolution or a y-axis and x-axis. So you got to be kind of careful there. Yeah, I did.
No, I got a point. I told him that telepathically.
Okay.
Just saying.
Yeah.
Look at him pretend to write down those things. He's just drawing a smiley face. He's like, these kids are chumps. Look at the shade and stuff.
No, he's playing Hangman.
Yeah.
All right. Next one. Moises, what is the radius of this thingy?
Number 7.
Yeah. Oh, that's number 7, huh? We want number 8. So Moises, what is the radius of this thingy? Okay, so it's negative y squared plus 4 because we have the function minus the axis of revolution.
Yep.
So the distance between them will be negative y squared plus 4.
You underlined the wrong thing for axis of revolution.
Huh?
You underlined the wrong thing for axis of revolution.
I don't think so.
It's you did underline the axis x equals negative 2.
X instead of yes.
You underlined x minus
It's the same thing.
Shut up, kid.
Oh, I see what you're saying. I see. Okay. It's not wrong though. All right, Devin. I'm not wrong. You're right. What's the formula for the area of the face, the circle?
Pi times negative y squared plus 4 squared.
Good. And then I'll ask Mario the area or the volume. I mean.
Pi times integral 0 to 2.
Cool.
See
That's
why Nick is still depressed that he didn't know that there's videos for
I think he's lost.
April Fools, there's not. You silly goose.
All right. Last question for the day.
That's number 10 already.
Quiet, please. Okay, so for each problem, find the volume of the solid that results when the region enclosed by the curves is revolved about the given axis. So we have x equals the square root of 3 minus y. I'm going to color code these for you. This one is on the right. And then this one is the one on the left, right? And then, of course, we have y equals -1. That's this line down here. All right. Now we're revolving it around the line y equals -1. So if I'm revolving it that way, that is a revolution for what? Dx or dy when we go that way. That's a dx revolution. So what's the problem? These are all in terms of x. So you got to watch out for that. This is kind of a corny question. Honestly, usually they're already written in terms of y, but you have to change it to rotate it around an x-axis, like a vertical axis. That's what's more common. But in this case, we'll go ahead and play the game. Since we're rotating it around a horizontal axis, you need to change these so that it's with respect to x. All right, so what do I do?
Square.
Square root of both sides.
Not square. Square.
Oh yeah.
Next,
Subtract 3.
next.
Divide by -1.
Now, there's another one over there, right?
Yeah.
But they're going to give the same thing. Do you guys see that? If you start by multiplying both sides by a -1 to get rid of that negative on the outside, and then you square it, you end up with the same thing. Do you guys see that?
Yeah. Because the negative goes away.
The negative goes away. So instead of having two curves, you end up with one when you change it back to a y. So now I'm looking at only one curve here, which is this.
Oh, that's so cool.
Okay. So what's my radius?
Radius
Yep.
is 3 minus. Oh wait, no, it's 3 minus. I mean, x is -x is second minus 2.
3 minus x squared.
3 minus x squared.
No, wait a second.
Minus what's my axis?
Minus -1.
Good. So my radius
Isn't it 4 minus x is. Yes! Okay, I was close enough.
All right. So then the area would be pi that squared from what to what?
-2 to 2.
Yes.
Don't forget your dx.
Yeah, you forgot the dx.
All right. So as you guys can see, it sometimes the axis of revolution is like in this case it's a dx revolution, but up here they gave you dy equation, so you had to convert it. So you have to watch out for that. Yeah. Yeah.
So you could never change the axis of resolution. You have to change the.
No, yeah, you'd have to change the equation. You would have to change